Okay, 58 has an airplane and it's traveling at 125 kilometers per hour. And it's going to drop supplies. So it's going to drop something, and it's going to fall like that to shipwrecked victims that are floating on the ocean. And it's 1,001 meters from there to here. So this is basically a projectile problem, and it wants to know how many seconds before and what horizontal distance. So it wants to know a couple of things. What is this distance and the time? So it's kind of like the last problem, well, not the last problem, but like number 52. So what I'm going to do, I'll break this into its vertical and horizontal components. VI, VF, A, T, and D, velocity, distance, and time. So vertically, acceleration 9.80, distance 1,001 meters. So I can use all these pieces to find my time using this equation. D equals VIT plus 1/2 AT squared, 1,001, 1/2 9.80 T squared. So T, take 1,001 times 2 divided by 9.8, take the square root of it, and I get 14.3. So that's part A, assuming I have the right significant figures, 14.3 seconds. Now, the horizontal part is tricky because this is in kilometers per hour, so you can't write 125 down there. You have to take 125 kilometers per hour, and you have to change it into meters and seconds using dimensional analysis. 1 kilometer is equal to 1,000 meters, and 1 hour is 3,600 seconds. So you take 125 times 1,000 divided by 3,600, or you just divide by 3.6, and you get 450 meters per second. No. 125 divided by 3.6. And you should get 34.7. That's right. Okay, so this is 34.7. And the time is the same, 14.3. So velocity equals distance over time. Velocity being 34.7. Distance unknown, time 14.3. So you take 34.7 times 14.3, and you get 497 meters